So, I have a question asked by Maharshi Sharma, and the question is, sir, when we use the definition that potential at a point due to a source charge is defined as work done per unit test charge by external agent in moving it from infinity to that point without changing kinetic energy, can we consider dr vector along the direction of the external force vector? And then he says that he has gone through many physics books including concepts of physics, but did not find the answer. Why is it necessary for dr vector to be along the increasing direction of r? That is the main question. Why it is necessary for the dr vector to be along increasing direction of r? So, the question is, I have a charge say q1 here, and then a test charge q2 is brought from infinity to some distance r, say this is r, or some distance say r naught, and to bring it from infinity to this r without changing kinetic energy, without causing appreciable acceleration, what the person has to do, that external agent has to put a force in this direction. Assuming both positive, this charge will repel q1, will repel q2, and if you just want to bring it slowly, then the same amount of force should be applied in this direction, and then you can bring work done by this force. As this test charge comes from infinity to this place r naught, that is the potential at this point. Now, to calculate that work done, what we do is, work is force times displacement, and then it is on the same straight line. So, we write this force as minus F, because this is the direction, positive direction we have taken, and then dr, we just like dr, although the particle is displaced in this direction, but that change, that dr, the change, the distance, we write as dr, and that is the problem with Maharshi, understanding why for f I am writing minus f, but for dr I am writing dr, not minus dr. Our increasing direction is this, and this dr we are writing here. So, why we are doing that? We are doing that because after that we will do integration, remember. After that we will do integration. We will say that this is the small work, and the work is minus f dr, which is minus q1 q2 divided by 4 pi epsilon naught r square. This is the force, and then dr, and we will integrate this from minus infinity to plus infinity, and we will use integration formula. Integration of minus 1 by r square is 1 by r. So, it is q1 q2 and then 4 pi epsilon naught, and then 1 by r, and the limit is r naught here and infinity here, and that is q1 q2 by 4 pi epsilon naught r naught, and therefore, the potential which is per unit turns out to be q1 divided by 4 pi epsilon naught r naught. Now, in the process of integration, we are writing the initial value of r here, we are writing the final value of r here, and then this dr is by definition has to be increment in r. The dr itself may be negative, but dr by definition is increment. What is dx? What is dx? Initially you have x, and then this x becomes x plus dx. That is how in the entire calculus we define dx. Dx is the increment in x by definition, and using this definition only all these formulae of integration and differentiations have been established, that integration of minus 1 by r square is 1 by r. When I am using this, I have to follow this rule that dx is always increment in x. Similarly, dr will always be increment in r, and hence we write dr not minus dr. Dr itself can be negative, no problem, but we have to write dr not minus dr, okay? And then you get the consistent result. So, it is this definition of this incremental quantities dx, dy, d theta, etc. It is always increase in that. So, that we have to write.